Okay, so here we are inside of a construction program. I'm going to go ahead and grab the C# class here, the constructor class. I was thinking we could like prototype like some kind of simple program and just construct it using codex.
Do a XOR encrypted string.
Cool. So first we're going to create a method called XOR Encoder, takes string string S, returns string, right? Does that sound good?
That sounds good.
Okay, cool. Let's try it. Okay, here we go. New method XOR encrypt takes string S, returns string. Does that look okay?
Yeah.
Okay, now for the comment, we want to say what you were saying.
Takes the string and using the XOR function encrypts it with a static key.
Okay, well, can we say XOR encrypt a string and return a base 64 encoded result? How about?
Yeah.
Okay.
Yeah, I like that.
Okay, that's better. Okay. Add comment XOR encrypt a string and return a base 64 encoded result. There we go. Okay, and now we want to ask Codex to fill in the method body. So we need to estimate about how many tokens we want returned. What do we think?
I mean, realistically, it's probably could be done in under 10 lines of code.
Okay, so that's about 200 tokens, roughly.
Okay.
So let's try that. Okay. Codex tokens 200. All right, let's take a look. I mean, it looks like maybe it got it in even less than that, unless it's using. Well, yeah, it gives a decryption function as well. But let's evaluate this. So there's your key you were talking about, and then we got our results, and then we go through each character in the string. We turn it into an integer. What's this operation? Oh,
that's the XOR.
Okay. Oh, all right, cool. So we XOR each integer with the key, which is 13, and then we basically string build after we convert it back to a character, and then and then we call this library, which is a .NET library, convert to base 64 string with the ASCII encoding of the byte array. So that looks pretty much correct, right?
Yeah, I don't see any issues with that.
Nice, cool. And then it gave us a decryption. So so that's a nice bonus. Okay, cool. So that was pretty easy.
Yeah, so it looks like
Cool.
that interpreted exactly what I expected.
That's really nice. How about we try an RSA encryption? Same kind of thing.
Yeah, I think most of the encryption algorithms want a byte array, but I'd be kind of curious to see how it casts it and encrypts it.
Okay, cool. So we'll do RSA encrypt string S string key return string. We'll start with that. Okay, here we go. Add method RSA encrypt takes string S string key returns string. Okay, looks good. And then we can add a header comment on this. We can just say RSA encrypt a string with a key. Is that enough, do you think? Do we want to spice it up with anything else?
No, I'm kind of curious what it defaults to, because obviously there's different length RSA keys, and there's different ways of handling that. So we'll see if it panics or gives us something weird.
Okay, cool. All right, let's try that. Add comment RSA encrypt a string with a key. Yeah, we did 200 last time, right?
See if it does a decryption function as well.
Yeah, who knows? We'll see. Okay, here we go. Codex tokens 200. Yep, it sure did. Didn't quite make it all the way through, but that's all right. Cool. So it is doing a byte array for the, and with the text encoding UTF-8 of the string, and then it's going to set up a byte array for the return. It looks like, and then it's using this library. It looks like RSA Crypto Service Provider. That is probably a .NET library, and then it's doing from XML string on the key. So that's kind of interesting.
Yeah, that's interesting.
And then this library has an encrypt function. It's going to take data. Yeah, there's data, right? There's some parameter we don't know. And then it's going to, again, convert to a base 64 string from the encrypted data. So it looks like it's just depending on some kind of library, and then whatever that, I don't know what the relevance of the XML piece of this is, but that would be something we'd have to look at.
Well, I'm impressed.
Okay, cool. Add method. Create Bitcoin wallet, takes string seed, returns key value pair. There we go. Add comment. Create a Bitcoin wallet using a seed string and return the public and private key. There we go. Okay, so you want me to just do like 500 tokens on this one?
Yeah, we'll try that.
Okay. Codex tokens 500. Okay. Totally different stuff here. So it's calling the wallet a key value pair. It's calling the master key a key value pair and the child key. And then it's an array of key value pairs, 10 of them. And then there's secret, I guess would be the private, and external would be the public. Public key makes a new public key, and 10 of them. And then create master key using the seed. That's interesting. And then master key has a private key attached to it. That's how that works. That makes sense. And then they set the public key, and then create 10 child keys. So it iterates, and then at each of those arrays that were defined, at array locations that were defined earlier, there's the key and then the public key. So I guess that would be the private key, and that's the public key for 10 of these. And then the child keys get saved to the wallet, and then the public keys get saved to the wallet as well, and then you return the whole wallet. But this is pretty cool. So we have our XOR encrypts and decrypts. We have our RSA encrypts and decrypts, and then we had fun with creating a Bitcoin wallet. Like, that was pretty straightforward in terms of like a little collaborative prototyping session.
Yeah.